this. Okay, we're gonna start here. We have can you guys hear me? If you can,
I can hear you.
okay. Great. We have 9 students in the class, and I'm just gonna try this because today we don't have lab. So after this Zoom meeting is over for today, okay? But next week we will move to classroom. I know see we only have 5 connected to the Zoom meeting here today. But I recorded it, so hopefully somebody can see it afterwards. I know there's Blaine emailed me. He said he doesn't have internet connection. So next week we will start in class. We'll start in class. We will have lab. So this is one here. But I'm just gonna try it out, just to want to make sure in case we need to do this online, we have something that we can make it to work, okay? Now, when we come to classroom, I will require everyone wear a face mask, something like that. So now if you don't have one, the school has some in every building. Okay, school has some in every building. And they require instructors to wear a mask during lecture. Okay, so I will have to wear a mask during lecture. That's the requirement the school requires for the protection of students and the faculty member. So if there's some reason that you feel uncomfortable, wear a mask, or you feel sick, you don't have to come to class. Every class will be recorded. Every class will be recorded, just like today's. I'm recording it. I'm recording it. So your pictures will be on the recording, okay? And this one here. So let's come back to this lecture and the lab situation. Let's come back to the syllabi that I attached on Canvas. Certainly that's my office hour, which we're not required to stay in office. Doesn't make a whole lot of sense, isn't it? You're supposed to have a office hour, but you don't require to be in office. So if you guys need to get hold of me, email me first, okay? Don't just go to my office. I don't want you to make a empty trip. So email me first, and then if we need to make a face-to-face meeting, I'll wait you in my office, but email me first. So that's what is on the syllabus. Let me see if I can share the screen here, the syllabus here. Okay, so we have class meeting is Monday from 12:30 to 4. It's kind of weird in between to put a 35 minutes in between 2 classes. We're not gonna have that 35 minutes. I'll just keep going. I'll do some lecture, then we'll do the lab. okay, then we'll do the lab. And the method of instruction is going to be blended. That means in case we need to do it online, we will. Okay. And now, next thing here is textbook. This textbook is recommended. It's not required. It's not required. If you gonna go on MET232, I would suggest you to buy it because in that class, we require this one here. If not, I would suggest you not to buy it, okay? If you take this class and then that's it, then you don't have to buy it. I heard it's an expensive book. It's a paperback, but very expensive. Okay. Now, if you have a question, just speak out. Okay, you can interrupt me. And now, the class description, it says a general survey for various components and operations in automated manufacturing systems. Okay, we have another. Let me. Tamarick is joining us. Hello, Tamarick? Can you hear me? Tamarick?
Yes, I can hear you. Can you hear me?
Yes, yes.
Okay.
Okay, great, great. We were talking about the class. So next week, we'll be meeting in the classroom, Wilson 160.
Okay.
But you will be required to wear a mask, face mask. And now we also talk about, so that's next week, okay, that's next week. And we talk about the textbook. We don't have a textbook. You are not required to buy a textbook. And oh, here. Okay, you're not required to buy a textbook. The contents, that's a little bit interesting for the contents. I think I'm gonna have to, since last semester is really kind of a washed down semester, I will have to do lots of reviewing in the electronics, the MET101, which is the electronics. I will have to do a lot of reviewing that, and also probably I'll have to, even today, I'm gonna explain some in MET, some contents in MET100. MET100. We are dealing with the electricity, basically. We're dealing with the electricity. Okay, so basically we're dealing with electricity. We try to understand the automated manufacturing system, those including from sensors to the control system, from sensor to control system. So that's this class here. Now, for the grades, that's a grades here that you can see the composition of the grades. One is class participation. Now that's really kind of that's kind of hard to measure. Used to be attendance, but this semester we're not required to keep attendance. For any reason, if you don't feel comfortable coming to school, you don't have to. Okay, so this one here. And then we have homework, very few homework. And we'll have two tests. We'll have our final exam. And then we, now, so the class participation in the homework is gonna be primarily, the lab. It's gonna be the lab. Okay, it's gonna be the lab. Let me see, Jonathan just joined us, connecting.
Gonna go right here.
Hello? Jonathan. Can you hear me? Okay, any questions so far? Any questions so far? So next week we will be in the classroom. Okay, we'll be in the classroom. That's next week. And we'll go, let's see, share screen. This is one here. Now, lab reports, every time we will have a lab report, which is this class. It's because of it's an entry-level class, so the lab report can be very simple. I'll let you know, okay? I'll let you know. You can just report what you did in the lab. That's about it. All right, so this is one here. And if you make everything go into the 90 above percentage, you'll get an A. 80 to 89, you'll get a B. 70 to 79, you'll get a C. So this is class here. This class. It's not a very hard class, but it's very useful. We are talking about electricity and automated manufacturing system. The automation system in your home, for example, the heating and air conditioning, and that is a quite automated system. We should be, by the end of the semester, we should be understand at least that part of the system. Theoretically, the principle, we should understand those. And then there's a bunch of stuff that the school require us to post in the syllabus. I think every syllabus is going to be the same. Every syllabus will be the same. The school require us to do that. You too. Okay. There's a long attachment here in the syllabus. Okay. We're gonna, any questions? Any question about the class arrangement? Okay, here, there's a little bit of information here. This screen here, schedule and the topics. We will talk about we will review, we'll talk about electronics, some of the electronics, including transistors. I didn't write transistor over there. Sensors, we'll talk about sensors. And the sensor nowadays is connecting to transistors. Transistors diodes, and we'll talk about electric power control, SCR, triac, diac, and we'll talk about the relays and contactors, motors. And then we'll have an introduction to PLC. Okay, introduction to PLC. Any questions so far? I'm gonna stop sharing this screen here. Because we don't have a textbook, I'm gonna ask you to try your best to take your notes. Okay, so prepare a pen and a notebook to take notes. Okay, so this is one here. Now, as I said, we're gonna probably spend a lot of time. Can you hear me? Okay, yeah. We're gonna spend probably a whole bunch of time reviewing the contents in MET100, but it will be different. It will be different. And MET101, okay, it will be different. For example, for MET100, we know that if we have, let's say if we have a conductor, two conductors, and if we have two, I don't know if we can see it, two conductors, if we have two conductors. Now, if those two conductors, and if they carry a voltage, let's say they carry a voltage V1, V2, or E1, E2. Okay, so they carry an electric voltage here, E1, E2. Okay, E1, E2. As long as there's a voltage difference, okay, so if you have a voltage difference, it doesn't have to be positive and negative, as long as there's a voltage difference. And if you put a load in between those two lines, we call it a load, or whatever, or a conductor, or whatever, and you close the loop, you will have current go through it. It doesn't matter which way. Let's say if this way, if it goes this way, you will have current. You have current goes through it. So you will have current. Goes through it. Okay. Now, certainly at the very beginning, we are talking about a DC, direct current. That's what we find out at first. It's DC, direct current. We find out the DC first. And in DC, we use a positive and negative, okay? Positive and a negative. Let's say you have two poles. You will have two poles, and those two poles, positive and negative. Again, if you're connecting the poles positive and negative with a wire, a load device, or whatever, conduct electricity, then you will have current. Okay, you got to close the loop. If you close the loop, then you will have electricity. I don't know if you guys can you see it? Or maybe I
need, kind of.
Huh?
Yeah, kind of.
Kind of? Okay. Do I need to adjust my light? Maybe I need to adjust my lighting. Let me, hold on just a second. Let me.
I was about to say, the lighting's not that bad. It's just kind of just pencil on paper.
Oh, lighting is not bad?
And kind of gets to it.
Okay, so I need to hold it steady, maybe. All right. Now, at the very beginning, it is DC. Now, at the late 20th century, no, 19th century, late 19th century, you guys probably heard of the story. There's a guy called Nikola Tesla. Nikola Tesla. This actually is a Czech guy, Czechoslovakia. Not Slovakia, it's a Czech guy. He was born in Czech. Nicholas, I think it's Nicholas Tesla. Tesla. Just like the car, Nicholas Tesla. Okay, Nicholas Tesla. This guy here. You guys probably heard of this guy. And he's really a genius. He's really a genius. He's also very unselfish, very unselfish. He doesn't patent anything. He didn't believe patent. So he doesn't patent anything. He publicized all his inventions, And during his time, while he was working for Edison, Thomas Edison, we know Edison, right? Thomas Edison. And this guy, he moved to, from Europe, he moved to United States. And then he works for Edison. Edison pay him nuts, but he's okay. He has a lab, he works there. Then he found out something interesting. He said, well, the current at that time, okay, the current doesn't have to be always go from positive to negative. You have two poles, you can alternate it. You have two poles, you can alternate in them. How do you alternate them? By changing the magnetic field. Okay, by changing the magnetic field. So what he does is that he invented something, just changing magnetic field. So let's say if you have a rotor and then you have a coil. So that's a rotor here. Rotor is a cylinder, okay? If you have a rotor and on top of the rotor, you attach a coil. A coil is an electric conductor, a copper wire. You attach a coil. And this coil will generate a magnetic field. And this magnetic field will be moving. Okay, the magnetic field will be moving. Now, let's say if you have a coil here. You have a coil here, you have a coil here. Now, if you're rotating, this magnetic field is moving, Let's say if you have a north and south magnetic field, we're talking about north and south. Electric field, we're talking about positive and negative. Now, if you have a magnetic field, north and south, if you rotate the rotor, what's going to happen?
Right.
If you rotate the rotor, yeah, the north and the south is going to flip, right? This is north. And then once you rotate 180 degrees, this becomes north, right? So the magnetic field is moving. And then this moving, it creates an interference with another magnetic field we set outside. Okay, so if we set another magnetic field here, north and south, this is not moving. That's not moving. That's something we call a stator. Okay, this is a rotor, this is a stator. and this is not moving. Can you see?
Yeah, I did.
Okay. Okay, so that's not moving, and then this is moving. They have interference. That's gonna create. That's gonna create electric potential. That's gonna create electric potential. Electric potential. My handwriting is kind of bad here. Electric potential. So it's going to create electric potential. And this electric potential, if you have two poles over there, let's say if you have two poles here, if you have two poles here, and this electric potential now, this time, if you draw it, this is time, this electrical potential, let's say E here, it will changing like this. It will changing like this. It will be changing like this. Okay. And since it goes to positive, negative, it always change, always change, always change. And we call it AC, alternating current. We call it AC, alternating current. AC. Okay. Now, Thomas Edison absolutely hated it. He doesn't like it because it's so complex. He doesn't like it. But Tesla, Nikola Tesla, he published that. He published that because Thomas Edison doesn't like it, and he published that. And then there's another guy called Westinghouse. Probably you guys know this name, Westinghouse. It's called Westinghouse, this guy here. And now Nikola Tesla, he's a guy that is weird. Okay, we have Nikola Steele joining in. We're talking about Nicholas, and Nikola Steele is joining in. Hello? Hi. Can you hear me? Okay. So Tesla, he joined Westinghouse. He joined Westinghouse and generate power, generate electricity. At that time, the United States, that's 1870s, 1880s, and 1890s. Those are the years that Nikola Tesla was working on. We will talk more about Tesla's invention when we talk about a three-phase motor. That is really interesting, okay? That is really interesting. So at that time, they started generating power. At that time, New York is an economic center of the United States. But Edison has monopoly power because electricity by nature is monopoly. Once you have wire set up to your house, you cannot have second wire. You only have one set of wire. You cannot have a second set. So it's natural monopoly. And Thomas Edison definitely monopolized the power supply for New York City, So Westinghouse, they can only supply power to the suburbans of New York, not New York City, not downtown New York City, not Wall Street or whatever. And now, what's the advantage of AC over DC? AC over DC. AC over DC. What's the advantage? The biggest advantage. The biggest advantage.
Go both ways? Or,
Somebody say something?
I think someone's on the phone.
Oh, okay. Yeah. The biggest advantage is the voltage of AC. Voltage of AC. Voltage of AC can be very easily manipulated. Okay, you want the voltage to go up, you put a transformer. A transformer So you put a transformer over there. We want you to know this thing here because we will use transformer in the future, okay? You put a transformer over there. Now transformer is a very easy, very simple equipment. Very simple equipment. Very easy, very simple equipment. What is a transformer? A transformer basically is some kind of iron. Some kind of iron. So that's a piece of iron. And on this piece of iron, you form a loop, so that the magnetic field can go from this side to this side. And then you have a coil, you have a coil here, you have a coil, you have another coil here, another coil here. Okay, you have two coils, transformer. It's just simple like this, just simple like this. So it's a very simple equipment to make. And now the voltage here, let's say V1, V2, the voltage V1 and V2 is in reverse reciprocal to the reverse proportion to the number of coils, Let's say that's N1, N2, number of coils. So V1 over V2 is equal to N2 over N1. N2 over N1. Okay, here, you see that? N2 over N1. Okay, so this one is so simple. Now the efficiency also very high. Efficiency very high. And very normally, the transformer can go, for the industrial one, it can go to 99.9% efficiency. Okay, now at the very beginning, we only have 98% of efficiency. Now, where is that 2% go?
Heat.
Heat, yeah.
Yeah, heat. That 2% goes to the heat. So what we need to do is that normally we need to immerse this one here, into a big tank of oil, And then we have some fins, we will have some fins. You'll see, you go to some transformer station, you'll see some fins. What are those fins do?
The heat sink.
Yeah, dissipate the heat. Okay, so that's it. Nothing else. Very simple, right? Very simple. And now, one thing we got to be careful is that those oil before 1972, this tank of oil is a special oil called a PCB. It's called a, here, it's called a PCB. And this is a very toxic. This one is very toxic. You touch it, you get on your skin, you get a cancer on your skin. Okay, so be careful. Don't touch the old transformer. the old transformer before 1972. Before 1972. That's PCB is very toxic. Nowadays, they change the component. PCB is very good. That's the oil that has a very, very low melting point. You don't want to freeze in the winter, right? Has a very low melting point and also has a very high boiling point. You don't want to, like water, it's going to boil at 212 degrees, right? And when it boils, what's going to happen? You're going to have a
You're going to turn the gas and expand.
yeah, you're gonna have a huge pressure. You're gonna have an explosion, right? So PCB is very good for that, but it's very toxic. It's very toxic. Okay, and now Edison is not dumb. Okay, Edison is not dumb. He doesn't like AC, but he make a very good equipment. He makes a very good equipment. It's called a rectifier. It's called a rectifier. And this piece of equipment is making AC into DC. This piece of equipment making AC into DC. Okay, making AC into DC. So he keep his business running all the way to maybe 1894, 1892. I forgot the exact year. He keep his business running. So like New York City, they used DC all the way to 1982. Eventually, because of this piece of equipment, added cost, they lose to Westinghouse. They lose to Westinghouse. They went bankruptcy. Westinghouse just beat the hell out of it because they're so much cheaper, so much cheaper. And Edison is so much expensive, so expensive. So eventually, Westinghouse won, and Edison lose. And now Edison lose, but he makes very good equipment. Rectifier makes very good equipment. So he merged with another company called General Electric, GE. Have you heard of this? General Electric. They're making very good equipment. You probably have appliance from GE, right? They're making very good equipment. So GE go all the way from survived a century and more than a century, GE, General Electric. Okay, and certainly Westinghouse also is still there, a big company. Westinghouse is a big company over there. All right, now, so now, we have a transformer here. Here, we have this thing here is what we call a generator, Now on this rotor, you put a coil, this kind of waste. You can put more coils, right? You can put more coils. And you can put that's one set of coil, You can put 2 sets, you can put 3 sets, 4 sets. And eventually, we all settle down on 3 sets. 3 sets of coil, we settle down on that. Make use of the space, So like here, and then here, and here. So 3 sets of coil, 3 sets of coil. That's how we generate electricity. We make use of the space, make use of the space. Okay. Any questions? Any questions? Sorry, even the first day we are working on this here. And now we know the power is proportional to the strength of magnetic field. Power is proportional, okay, proportional to strength of magnetic field. Magnetic field, strength of magnetic field, okay? Number of coils, number of rounds, number of rounds in coil, number of rounds in coil. A coil has rounds, right? Has rounds. Number of rounds in coil, okay? And size of coil conductor. Size of coil conductor. If you go see a big power plant, you'll see the size is like the conductor is this big. Okay, this big. It's very big, huge. That's copper conductor, very big. Size of conductor. Another thing, rotation speed. Rotation speed. Rotation speed. Proportional to that. And certainly we want to have more power, but the rotation speed demands, put a whole lot of mechanical demand on the machines, on the generator. If you want to rotate fast, your generator has to be very precise. So eventually, United States settled down on 3,600 RPM, 3,600 RPM. Okay, so the rotor rotate at 3,600 RPM. And no faster, no slower, 3,600. But interesting enough is that European countries, now Tesla invented this one here. He didn't patent that. So everybody knows how to make a generator now. And the European country, they're settled down on 3,000 RPM, 3,000 RPM. We are settled on 3,600 RPM, and they're settled on 3,000 RPM. 3,000 RPM. Okay, now this is revolution per minute, revolution per minute, revolution per minute. Now, if I'm asking you, what's a revolution per second? For example, 3,600, what's gonna be the revolution per second?
60? No.
It's gonna be,
You just multiply it by 60, right?
yeah, it's gonna be 60, right? 60 revolution per second, 60 revolution per second, 60. Now, revolution per second, revolution per second, revolution per second. We call this one, we call it frequency. Frequency. We call this one frequency. We call this one frequency. Now, that's very important, frequency here. Because later on, we'll talk about something called frequency drive. Frequency drive. And what is this? The frequency, you rotate at 3,600 RPM, that's a generator. The opposite of generator is a motor. It's a motor here. And I connect to a motor, my motor will run at 3,600 RPM. And so this frequency, we call the 60 Hertz. 60 hertz. And now 60 hertz. Okay. Now, with three sets of coil, and the electricity we generate, we call it a three-phase electricity. Three-phase electricity, three-phase. Okay. Well, today it's just a trial. It's just a trial. Okay. I will see you guys next week in class. See you guys next week in class. All right. You are required to wear face mask. And if you have a problem, if you feel uncomfortable, you don't have to show up. You don't have to show up. Again, every class will be recorded. I'll post this one on Canvas. I don't know how long it's going to take though, but I will post this one on Canvas. And next week, we will take a look at the three-phase. And also we'll take a look of the equipment, the control equipment in the classroom, okay? We'll take a look at that. And we will stop here today. Any questions?
Yeah. So you said you will post every class on Canvas for this year if you don't feel comfortable coming to class?
Yes, I will record. Like today, I recorded. I don't know whether it's going to be successful or not. I recorded, and I will post today's recording on Canvas. Okay, it might take a while.
For part two of this class, are we getting back on it too, or with the?
Good question. Today, that's it. We don't come back today, but next week we will. Okay, today we don't come back. Very good question. Any other questions? Okay. Well, you guys have a very good rest of the day, and I'll see you guys next week. Okay.
See you later.
All right, cool.
Thank you.